We want to solve this equation for x. In order to do that, we need to know about the properties of logs. So our first step will be to try to combine the logs on the left-hand side, which brings us to the sum to product rule here. X times x minus 2 is equal to log of 8. So we're looking at the form of this, and we notice that everything in this problem has a log function with it. So we can use the property that log m equals log m implies that m equals n. Since you have log of some stuff on the left equals log of some stuff on the right, that means their arguments have to be equal to each other. Now, when I distribute, I have x squared minus 2x is equal to 8, which is a quadratic type problem. We can collect all of our numbers and x's on one side and attempt to factor this. X times x gives me x squared, and 4 times a 2 would give me an 8. Since it's a negative 2, I'm going to put a negative on the 4 and a positive on the 2. Now, negative 4 times positive 2 gives a negative 8, but when I do the inner terms and the outer terms, I have a negative 4x and a positive 2x, which combine to give me the negative 2. So my factoring is good. Now I can use the zero product principle, which says that if I have two things multiplied together set to 0, that means either x minus 4 equals 0 or x plus 2 is equal to 0. So x is either 4 or x can be negative 2. Now, since we're dealing with log functions have a domain that says you have to keep the argument of the function positive. So if we look back at the original problem, we have to ask ourselves, is this part of the domain of the original problem? The original problem is at the very top. Can I use 4 here? Log of 4 plus log of 4 minus 2, or log of 2, that's okay, no problem there. What about this negative 2? Log of negative 2. That fails to work in part of the problem, so that root is not actually a solution to this equation. So our final answer is x is equal to 4.